Okay, good morning students. So we will continue the topic work, power, energy. Work, power and energy. Okay, so we have seen the difference between conservative and non-conservative force. Okay. Nitish, how to find whether a force is conservative or not? If you are getting a function, of force, okay, that function will have x term, y term, maybe constants also. So how to understand whether this is a conservative force or not? ஒரு வாட்டி பார்க்கணுமா? புரியல. Just when you talk out, you can remove this and say what formula? Y is equal to x or not? Y x ஆக முடியுமா? Okay, உங்க நெய்பர் பேரு? சுதர்ஷன் அவர்களே, tell me. Y is equal to x. Y is equal to x. If y is equal to x, then this is conservative force. இது நிதிஷ்க்கு சான்ஸ் முடிஞ்சது, அவ்வளோதான். இன்னைக்கு அப்பா கிட்ட இனி அப்பா கூட தான். சுதர்ஷன் அவர்களே சொல்லுங்க. தெரியாது, சரி. தங்கம், உங்க பேரு? கோகுல் தங்கம். கோகுல் ஃப்ரம் பொள்ளாச்சி. ஸோ குட். அவரு சொல்லுவார், பார்த்துக்க, பொள்ளாச்சியில் இருந்து தானே. சொல்லுவாங்க.
So by differentiating we get the answer for x and y is equal means
சரி, அது கொஞ்சம் புரியுற மாதிரி சொல்லுங்க.
dou x by dou y.
பொள்ளாச்சிக்கு பெரிய அவமானம். அந்த தங்கம் இது கொஞ்சம் கழட்டிட்டு சொல்லுங்க.
dou by dou y into fx dou by dou y of fx equal to dou by dou x dy dou by dz dou z fy equal to dou by dou y
சொல்லுதானே? தேர்ட் ஒன் ஆர்வம் ஆயிடுச்சு. Akshaya, is it correct? Is it correct? Okay. Merlin, is it correct? Merlin ku doubt irukku, idu correct irukka illaya? Idu paathirukka Merlin? ஏதோ ஸ்ட்ரேஞ்சர் தெரியாதவங்கள பார்த்துட்டு இருக்கிற மாதிரி இருக்குது. வீட்டுக்குள்ள some stranger is coming inside. No, how will you do? அதே மாதிரி இந்த ஃபார்முலா saying Merlin is looking like this. இது கரெக்டா சரியா தவறா? Dou F கரெக்ட் தான், கரெக்ட் தான். Aishwarya, correct. Okay, fine. So this is correct. This is how we will check whether a force is conservative or not. சரி, ரொம்ப ஆர்வமாக எழுதிட்டு இருக்கு இங்கே. இப்போ யார் சில ஸ்டூடெண்ட்ஸ் will not look at me, they will be busy doing something. உங்களை சொல்லலை, அவங்க. Your name? Riya baby. If it is conservative force, then what will be the work done in the round trip? If it is conservative force, zero. Correct? What she is saying? Okay, good. Done. What is the work done if the force is variable? Formula மட்டும் சொல்லுங்க. இன்டெகிரல் தான் வருமா? அது சொல்லுங்க. பரவாயில்ல, தேங்க்ஸ். அப்புறம் ஒர்க் டன் என்ன எழுதணும் உங்க? இன்டெகிரல் போட்டா இது this is the work done. F integration of F போதுமா? dx. Suppose if the displacement is this direction, என்ன பண்ணலாம்? dy. இப்போ the y is equal to 0 இலிருந்து y is equal to 3 meters வரைக்கும் displacement இருந்தா integral 0 to 3. அவர் பேரு பரத். Right, fine. Okay, done. So have you all revised? எல்லாருமே ரிவைஸ் பண்ணல. If you have revised, இது வந்து டக் டக்னு சொல்லிருக்கோம். So the only method to keep everything in mind is to revise the thing on the same day itself. Before coming to the class also just revise. Then after that, if you finish the chapter like that, you need not study at all. Things will be very easy. Okay, so try to be very lazy. How to become a lazy? Some students will try day and night, no, when it is near to the exams. Hardworking people, no, they are actually hardworking people. Okay, full night உட்காந்து படிச்சுட்டு மார்க் வாங்குறவங்க இல்ல, they are the hardworking people. Lazy people are what? On a daily basis, 20 minutes, 30 minutes, just keep studying. Okay, so spend less time but effectively, smartly. Okay, things will be interesting. Okay, so in email வந்து when I ask questions like this, if you are not thorough, if you are stammering, okay, or if you are stumbling, if you feel a little insecure, okay, என்னோட ரூபமே மாறிடும். ஓகே, இப்படி இருக்காது. நிதிஷே, this is the last chance, last warning. படம் பார்க்கறதுக்கு வரல, டெய்லி போய் ரிவைஸ் பண்ணிட்டு இருந்தா தான் all these things will be useful. புரியுதுங்களா? ஓகே, so no compromise. புரியுதுங்களா? No friendship if you don't study. Okay, done? Okay, right. So we'll continue. See children, if a force is variable, if force is variable means varying, if the force is varying, if force is not constant, then work done is what? Integral f dx. If it is x, no need of dot. Correct? Now what is integration graphically? Summation concept wise. Graphically? Area. So if we draw force displacement curve force displacement and area of that work done. So that is another point. Okay, the work done is nothing but the area under force displacement curve. So those who do not know, please mark this also. Clear? Done? Okay, so suppose if you get a question like this, okay, x a centimeter per second, a centimeter per second square, and this is x centimeter. This is the curve, this is 8, this is 20, this is 20. So this is the force displacement curve of a mass 10 kilogram. Clear or what? This is a force displacement curve of a body with the mass 10 kilogram. So in this case, what is the work done? In this case, what is the work done? Now, I'm sorry, what I said, this is force displacement, no, acceleration displacement curve. This is not force displacement curve, this is acceleration displacement curve. So, what is the work done by the body? The mass m is equal to 10 kilogram in this. Okay, what answer, pa? 16. D. Okay, 1.610 raised to minus 3, that is what you are getting. Okay, so what is the area? Area is half BH, correct? No, half BH. So we will be getting into 8 into 20. Going to be how much? 80 seconds per second square centimeter, correct or what? So this is the unit will be like a centimeter per second square into this is centimeter, correct or what? So what I should make it meter per second square into 10 raised to minus 4 meter per second square, meter square second square it will come. So this is area displacement curve, So along with that, if we need to find the work done, what we should do? We should multiply with the mass into this result. So what is the mass? 10. 10 into 80 into 10 raised to minus 4. So how much you will be getting? So this is going to be 8 into 10 raised to minus 6. Minus 2, yes, 10 raised to minus 2. Okay, so just instead of force displacement curve, they made it into acceleration displacement curve. See, if you multiply here with m, this is nothing but force displacement curve. So only thing is just multiplying with the acceleration will make it into force displacement curve. Correct, Dane? Clear? This is the area. This is actually when you do this integration. When we do integration of something, suppose if we are doing integration of something, we will be taking like suppose if it is like this, what we are doing is we will be taking a small part like this. After that we will be taking another part, we will be taking another part. Likewise we do differentiation, integration. So always whatever be the curve, you should consider the area under that line. Not this one. Always, if this is the curve, area under that curve. So this is the curve actually. So we should consider the area here. Clear? Done. Okay, fine. Next we will start energy. Okay. Now we have seen the fundamentals of work. Now we will get to the topic energy. Okay, so in energy, first topic we are going to deal is kinetic energy. Under kinetic energy, the first topic is so work energy theorem is nothing but change in work done. Okay, work done is the change in kinetic energy. Work done is the change in kinetic energy. So work is equal to delta K. This is what is work energy theorem. Work is equal to change in kinetic energy. So work is equal to half m final velocity square minus half m initial velocity. Simply we can say work is equal to half m into Vf square Vi square. Okay, so suppose if you are moving with a velocity, if someone pushes you, what will happen? Your velocity will increase. So he is doing a work on you. Okay, when he is applying force on you, he is doing work on you, so your velocity will be increasing. So that increase in velocity will be the change in kinetic energy. Okay, that increase in velocity will become the change in kinetic energy. So whenever we do a work, that work will come as in form of energy. Okay, if you are doing work against a conservative, that will be stored as potential energy. So you are doing, if that's not there, then it will become. So this is what simple theorem. Okay, simple theorem. Now we will do some problems on this, so things will be clear. Okay, suppose this is a question. Okay, so this is velocity time curve. This is a velocity time graph. So here it is 10, here it is 2 seconds. Okay, so this is a velocity time graph of a body with the mass m is equal to 2 kilogram. This is a velocity time graph of a body with the mass m is equal to 2 kilogram. Okay, what is the work? What is the work done? What is the work done? what is the work done in this process. Any answer? 100 joules. 100 joules. All of you got that answer? 100 joules. Okay, right. Minus 100 joules. Okay, let's see. Okay, so here, okay, let us see. Here no force, no displacement, nothing is mentioned. So if they ask work, okay, we cannot apply whatever we have studied till now. So here we will have to make use of work energy theorem. So work is equal to change in kinetic initial kinetic energy. So half m into Vf square minus Vi square. Always practice this structure. Always practice this structure, because sometimes one IIT advanced question is there. Mass is not given. They asked so many years before. Maybe some 15-20 years back, I believe. So that time maybe. So nowadays students will do. So they won't ask for J advanced now. But this asked this question for JE advanced so many years back. They haven't given mass. They did not give mass, but they have given velocity. Okay, the thing is that this velocity square and this velocity square, their difference will become 0 in that answer. Mass is not required. So if someone searches for mass in the question, and if they leave the question, they will not get answer. Okay, so you should concentrate here, then search for mass. Okay, that thing is there. Right, children. So here, what is the initial velocity, Tangams?
0. 10.
Initial velocity means always this is 0. Time will proceed like this always. 0, 9 o'clock, 10 o'clock, 11 o'clock, 4 o'clock. So always the velocity corresponding to this time will be the initial velocity always. Okay, so we final here. Okay, so this is going to be 0. So half into mass is going to be 2 and this is going to be 100.
0.
I'm sorry, 0 minus this is going to be 10 square earlier. So what will happen? This is going to be minus 100 joule. This negative is the part of the equation. If we are taking velocity as minus value because of direction, that minus of square will become plus. Since this is square, don't cancel out this minus. Need to be very careful. Okay, simple silly things. Okay, so answer is minus 100 joule. Clear?
Previous question we have taken the area, no sir. Inge area edukama we have used this.
Adu and aal vandu Raju, idu Mani. That is Raju. This is Mani. Raju vandu, this is acceleration, this is displacement Tangam. Kekalam, you should ask any kind of question you get in the mind. Okay, you are the teachers, I am the student. Kekalam, kandipa kekalam. Okay, and the manavali vendadil. Okay, that is the first thing. Okay, when I explain the things, everybody will laugh. That is not only for this one, for everything. That is because we should not sleep. Otherwise I will sleep. Look pa, this is acceleration, this is displacement. What is this? Velocity, this is time. Adu Mani, idu Raju. Randukume sambandhame illa. Here we are trying to find the work done using force displacement concept. So force displacement concept, we have used the integration, right? Integration is nothing but summation, which is nothing but area mathematically. That is why we are taking area here. Ippadi irukumbodhu we take area. But here nothing like that. If you want to take area of this, I will show you. Okay, if you take area, this is nothing but half BH. So half into what is base? Time. So time into what is height? Velocity. So what you will be getting velocity into time? Okay, velocity into time, if you do, you will be getting displacement. So half of the displacement is what we are going to get. Half of the displacement, we don't need it. Who will ask for half of the displacement? If they ask something like that, half of the displacement, if they give a graph, then we can try. Correct or what? So this is the real meaning of this thing. Clear or what? Okay, see, I won't be thinking like half of this thing will give half of the displacement and all. I won't be thinking. When you ask the question, we will be trying. Okay, so thanks for asking that. Children, understood or what? Okay, so the answer for that question is minus 100 joule. Right. Another question. Mass is equal to 1 kilogram. Mass is equal to 1 kilogram. And the displacement happened is 2t square minus 2t plus 10. Okay, what is the work done in 0 to 2 seconds? A body of mass 1 kilogram, we have done it, already completed.
Last question we can do like this, you can take the slope pro area for x and a, then m into a into x, like that also you can do that.
எப்படி சத்தமா சொல்லுங்க.
Slope எடுத்த acceleration கிடைக்கும்.
Slope எடுத்த acceleration கிடைக்கும். Okay. So slope of velocity time graph is acceleration. Slope of velocity time graph is acceleration. So if we take the slope of this, so that is nothing but y1 y2 minus y1 divided by x2 minus x1. Understood or what? Another point what she is saying is slope of velocity time graph is acceleration. We have studied in one dimensional motion. So this is going to be 0 minus divided by what? 2 minus 0. Correct or what? Is it correct? Is it correct? Okay. So this is going to be minus 5 meter per second square. This is nothing but acceleration. So mass is there. So force is going to be what? Mass into acceleration. So force is going to be minus 10 Newton. Minus 10 Newton. Now if we want to find the work done. We apply panna vendam. Okay, so if we do like this, we won't be getting. Okay, so now what we need to do? Area. So area is equal to half BH. So half into 2 into 10. So we will be getting 10 as the area. So when 10 is the area, if 10 is the area, this into this mass minus 5 hour.
Minus 10. Force into displacement.
For this is area. What else we need?
Force is minus 10.
But where is the displacement? Area under this we can understand. This is acceleration that we got from the slope. Area under this one is half of the displacement. Abdiya.
Displacement.
Area of this one is displacement. Okay, what you are saying is okay, fine, I understood. Velocity time graph, area is displacement. Correct. So what is that?
Force is minus 10.
Minus?
10. Force is minus
Okay, force is minus 10. Okay, now area is?
10.
Area is 10. Now what? Minus 100 joule. Same answer, correct? Perfect. So one thing is, what I said is, this is half of the displacement. That is wrong. A velocity time graph, whatever displacement we are finding, that is full displacement. The area of velocity time graph is full displacement. Since I said half, I thought like this is half of the displacement. So this is correct. Understood or what? Clear? Purila. See, nothing. What they are saying is, this is velocity time graph. So in motion in one dimension, we have studied slope of velocity time graph is what? Acceleration. So that is what this thing. So now what is the force? Force is equal to this acceleration into this mass. So this we are getting minus 10. Now area of velocity time graph is displacement. So area of velocity time graph is displacement, means when we find the area of this, we will be getting 10. Okay, then what we are getting? This is nothing but force into displacement. Okay, konjam vela irukudhu, thappu varama paakano, avlodha. Okay, avlodha. Okay, so this is conceptually, this is also one approach, correct or what? Done. Okay, பாருங்க நீங்க ஒரு கேள்வி கேட்டதுக்கு எவ்வளோ படிப்பினைகள்ல எல்லாருமே புத்தியோட கலவர. Okay children, so what about this one? Baba, 16 joule. The work done 16 joule. 0 joule. Okay, oh, you are Hemant, na? Uday. Hemant? 0 joule. Any other answer? Okay, done? Any other answer? பயப்படாம கூச்சப்படாம ஆன்சர் சொல்லிட்டே இருங்க. Come on. 1 2 3 0. Riya 0. 16. ஐஸ்வர்யா. Okay. மெர்லின் அவர்களே 2 ஜூல். பரவாயில்ல, நமக்கு நம்ம ஒர்க் தான் பெருசு. Hitting 16. Right children, see now this is displacement, so force is not given, so the best approach is work energy theorem, right? So if you differentiate displacement ds by dt, what we would be getting? 4t minus 2 கிடைக்குமா? டிஃபரன்சியேஷன்ல எல்லாம் டவுட் இருந்தேன்னு வச்சுக்கோங்க, டஸ்டர் எடுத்துட்டு அப்படியே டக்குன்னு தலை மேலே வந்துடும். ஓகே, ரைட் ஃப்ரம் த ஃபர்ஸ்ட் சாப்டர் ஐ டிட் நாட் ஸ்டார்ட் ஃபிசிக்ஸ். பிஃபோர் ஸ்டார்டிங் ஃபிசிக்ஸ் ஐ ஸ்டார்டட் மேக்ஸ். யூ மைட் பி ரிமெம்பரிங். இங்கெல்லாம் ஃபண்டமெண்டல்ஸ் இங்கே என்ன ஆகக்கூடாது, ஸ்டக் ஆகக்கூடாது, அதுக்காக தான். ஸோ திஸ் இஸ் வெலாசிட்டி, கரெக்ட் ஆர் வாட்? ரைட். So 0 to 2 seconds. So we can say final time is what? 2 seconds. Initial time is considered as 0. So final velocity will be how much? 4 into 2 minus 2. 6 meter per second. Initial velocity is going to be what? 4 into 0 minus 2. Minus 2 meter per second. Right, so now work energy theorem is equal to half into mass is given 1 into 6 square minus 2 the whole square, correct? So half into this is b, so 32 joules is the answer. Clear? Okay, so வித்தியாசமா ஆன்சர் வந்தவங்களுக்கு புரிஞ்சுதுங்களா how it is coming? Okay. Okay. Another question. Initial velocity is given as 3i minus 4j meter per second. Final velocity is given as minus 6j plus 2k meter per second. Okay. Find the change in kinetic energy. Find the change in kinetic energy. Find the change in kinetic energy. Mass is also given, okay? Mass is equal to 0.8 kilogram. Find the change in kinetic energy. Options வேணுமா? சரி, ஒவ்வொருத்தர் ஆன்சர் சொல்லுங்க, ஆப்ஷன் போடலாம். Minus, okay, Uday minus joule dane. I. Sorry. 6 joule. Okay, then any other answer? Minus 6 joule. So 6 joule illana minus 6 joule avlodha. Okay, no other answer. Okay, so this is the formula, right? In the formula the correct form வந்து kinetic energy oda vector is equal to VF இப்படி தானே வரும். இப்படி வருமா? Kinetic energy vector is equal to half V vector square minus இப்படி வருமா? வராதுல்ல. இது யாரு? இது ஸ்கேலார். அப்ப இங்க என்ன போடலாம்? இங்க ஒரு magnitude மட்டும் தான் தேவை. Okay, only magnitude is required. What a magnitude எவ்வளோ? Initial velocity, its magnitude is going to be root of this square plus 3 square whole square. 9, 16, 25. What will come? 5. What is final velocity? Root of minus 6 the whole square plus 2 square. So what will come? Root 40 அப்படியே இருக்கலாம். Okay, this is going to be root 40. This can be kept as root 25 itself. Okay, why to waste time there? So this is going to be எப்படி இருந்தாலும் square ஆக போகுது. So final velocity is going to be 40 minus that is going to be 25. Correct or what? Into 0.8. Okay, 0. This is mass. Okay, mass. So 0.8. So என்ன வருதுப்பா? 15 into 0.8 divide by 2. என்ன வரும்? 6 joule. 6 joule is the correct answer. Okay, clear? A 5 kilogram ball, okay, acquires a speed of meter per second. Okay, find the work done by air resistance. A 5 kilogram ball falls from a height of 20 meters, acquires a speed of 10 meter per second. Find the work done by air resistance. If you are getting some, please tell me, we will make it options.
Hmm?
250 joule. That's the answer. Nidishkar? என்ன ட்ரை பண்ணுறது கொஞ்சம் பார்க்குறேன். ஓகே, ட்ரை பண்ணிட்டு இருக்கு. 750 750. ஓகே, திஸ் இஸ் யுவர் ஆன்சர். உங்களுக்கு ஓகே. எனி அதர் ஆன்சர்? 750. minus 750. Some competitive options. All are meaningful options actually. Okay, any other answer? Last chance. யாருக்காவது வித்தியாசமா? எனக்கு தனியா ஒரு ஆப்ஷன்ஸ் தப்பா வேணா சொல்லலாம். D. ஒரு ஆன்சர் கிடைச்சது தப்பா சொல்லிட்டு தனியா ஒரு ஆப்ஷன் வேணுமா? minus 250 விட minus 250 joules. Yes, options are done. See children, now this one, if this is a ball, okay, if it is coming, if this is 20 meters, so the velocity it acquires just before touching the ground is going to be 10 meters per second, and here velocity is going to be 0. What they are asking is air resistance. Now one, that is nothing but gravitational force. The work done by gravitational force will be there. Another thing is air resistance. What will be the direction of air resistance? Always air resistance will be, air resistance always work against the motion. Train la poitu irukumbodhu air will be blowing on our face, right? If we change the direction, again air will blow on our face. That is what, against the motion air resistance will work. So what happens is, here work done is equal to change in kinetic energy. Did I mention any condition here? Work done by conservative force is equal to change in change in the kinetic energy, or work done by non-conservative force is equal to change in kinetic energy? Did I say something like that? Didn't say anything. I simply say work is equal to change in kinetic energy. Here I am going definition. Work by conservative force, work of non-conservative force, if any extent, everything together, the change in kinetic energy. Everything will come here. Okay. So all these forces together contribute the change in kinetic energy. It cannot take it selectively. That is the concept. Okay. Now what we can say? Work due to air plus work due to gravitational force is equal to what? Change in kinetic energy. So half into what is 5 kilogram into what is final speed 10 square minus initial is 0. This is how it is going to be. What is mg? Mg is 5 into acceleration due to gravity 50. So work done due to air resistance, okay, is equal to, this is going to be half into 50 into 100 minus what? Minus 50. I'm sorry, 50 into 10. 500 or what?
20
Height is 20. Okay, sorry. mgh is okay. Work. This is actually air, and this is what? Mass 5 into g 10 into 20. Correct or what now? Is it correct? mgh. Okay, correct. mgh. So what is this one? How much is this? Okay, so this is going to be 10,000. This is going to be 1000, and what is this? 250. So this is going to be minus 750 joule. That is the answer. Clear? Why minus 750 is coming? This is actually moving. The displacement is in this direction. Work done by air resistance is in the opposite direction. We haven't put any negative here. We do not know. We have no idea what is the work done by air resistance. Okay. Simply we put, but everything came as correct. Correct or what? Done? Clear? So one question is displacement and time as related as displacement and time, okay, of a motion. Displacement and time, t is equal to root x plus 3, okay, where x is done. Find the work done. Find the work done. Okay, find the work done in 0 to 6 seconds. Mukesh, this is good thinking. புரியுதுங்களா? Zero. சொல்லிருக்க கூடாது. So here root x is equal to minus 3. Root x is equal to t minus 3. So x is equal to t minus 3 the whole square minus 60 plus 9. So this is the distance. So velocity is, we know, dx by dt, correct? Velocity. So work done from 0 to 6 seconds, this is what they are asking. So initial velocity is going to be, if you put here 0, correct or what? Puriyadilla? All of you to understand? Okay, need not explain every steps. So this is going to be minus 6. Final velocity is going to be, if we substitute here 2, this will become 12 minus 6, this is going to 6. Now what is the work done? Work done is equal to half into m into vf square minus vi square. So half into mass into, what is final velocity square? 6 square, minus initial velocity is square is minus 6 the whole square. This is going to be. So this term and this term will be equal. So the entire result will become 0. Mass is not given. We are not worried. Clear? Okay, you will do, no, any questions based on this you will be able to do. Suppose if we get a question like a force is applied, a mass is displaced from 1, 2 to 2, 3. Okay, some one velocity is given, we can find the other velocity, right? Force into displacement is equal to change in kinetic energy. Force into displacement is equal to what? Kinetic energy, F dot S is equal to half m. This is possible, no? They can ask displacement, they can ask any velocity, they can ask what is the force, anything can be asked. Clear or what? Okay, so extension of concepts, basic concepts only we can extend to any level. Clear, children? So next concept is kinetic energy and momentum relation. Okay, kinetic energy and momentum relation. Okay, so kinetic energy and momentum. Okay, so nothing. Okay, already we know all this, but only just catch certain points, that's it. So half mv square, if we want we can write like a half into mv into v. So this will give us a relation like kinetic energy is equal to half pv. If we get a question like velocity is constant but mass is different, velocity is constant but mass is different means momentum will be different. So if in that case what we should do, k1 by k2 is equal to p1 by p2, this throw this half and v somewhere, solve the problem. Likewise they can ask. Okay, so this is one formula of kinetic energy, this is second formula of kinetic energy. Third one, half mv square. We'll put a square here and we will divide with an m. So this is nothing but, this is momentum square. So k is equal to p square by 2m, p square by 2m, and they like this formula. P is equal to root 2mk very much. Okay, they like this one very much. Enga ponalum we will be able to see this. Okay, so this you must remember. Okay, konjam adhigama gavanam edukano, konjam naughty baby, konjam naughty, so we will have to be a little bit careful about this person. Okay, okay children, now suppose if we need to draw the graph of all this. Okay, see, okay, suppose if we need to draw the graph based on this kinetic energy and velocities. Okay, suppose if this is kinetic energy and if this is velocity, how should we draw? Velocity, kinetic energy and velocity. See, anywhere, see, suppose y is equal to x square. This is the equation of parabola. In maths, what we will be getting? We will be getting this shape. Okay, mathematically, y is equal to x square, parabola, y is equal to x, what? Straight line. Likewise, so same way, y is equal to x square. So if the kinetic energy is in y axis and the velocity is in x axis, what will be the thing? When time is in the x-axis, you can notice that this will be cut. Only right side we used to draw. That is why in motion in one dimension, you might be remembering all the graphs were like this. Either this one or this one or this one. Because those were displacement time graph, velocity time graph, like that. No, this is nothing but kinetic energy, velocity. Same kinetic energy is possible. Suppose if this is 4 meter per second. What is kinetic energy if the mass is 1? 8 joule. Kinetic energy will be 8 joule. This is 16. 16 by 2, 8 joule. Suppose if this ball is going in this direction, mass of the ball is 1 gram. So this is going to be 4 meter per second. Taking the same ball, he is throwing back. Now this ball is going in this direction. If this is plus, we should consider this as minus 4 meter per second square. So for minus 0.4 meter per second also, what we are getting? We are getting same 8 joule, whatever we are getting. So same value is possible. That is why we will be taking both the directions, since this is velocity. If it is time, we will be taking only half. Fundamentals. Okay, remember like that. Okay, now idhe madri half mv square madri, what is also there? Kinetic energy is proportional to momentum square also. Okay, so if we want, we can put like this is going to be, this is applicable for momentum also, clear? So we should understand one thing here. You should put m is equal to constant. Clear? Previous graph also, when we took this, consider mass constant. Here also mass constant. Mass will be always constant, that is agreed, but still, okay, for safer side, mass will change, no, in nucleus, atoms and all. If that particle moves with a velocity almost near to light, 10 raised to 6 meter per second velocity, if it gets, definitely mass will change. Correct or what? Okay, so this is mass constant, right? Okay, now suppose this formula. Okay, so this formula, let us take this formula. This one we have taken. Now suppose if the momentum is constant, and if the mass is varying, how we will draw this? Hyperbola inverse. So what will come? So this is going to be, okay. Okay, so kinetic energy, and this is mass. Momentum is constant, so in that case we should draw like this, inverse proportion. Here, this one. Nitish, Tangam. Okay, what about this one? Momentum and root of kinetic energy. Momentum and root of kinetic energy. Every podla. Root, here it is P. Straight line. This is direct proportion, right? P is proportional to root K. Okay, so here also mass constant. Okay children, so another thing is, see, suppose if something is moving, some vehicle is moving, when we will be applying force against it, it will stop somewhere. We have handled such problems in motion in one dimension. Retarding force, vehicle will be stopping at some distance. So this concept we can integrate into kinetic energy concept also. Okay. Okay, so stopping of vehicle by retarding force. Retarding force. Stopping of vehicle by retarding force. Say for example, if a car if this is moving with a velocity u, nalla irukla car, okay, moving with a velocity u, okay, Benz car. Okay, now this is stopped here, so final velocity 0. Okay. Okay, so final velocity is 0. Now this is stop x. Okay, was moving with a velocity u. Now this is stopped at some distance. Okay, so final velocity is 0 and the distance covered for that one is displacement is equal to s. Okay, so now what is the work done in this process? Work done in this process is same, change in kinetic energy. The work done by the retarding force, we can say is acting in this direction. This is called the retarding force. So work done is equal to change in kinetic energy. We could say m is 0 square minus half m u square. Correct or what? Okay, done. So from this what we can say, what is the work done based on force and displacement? What we can write? The work done with respect to force and displacement. So work done is equal to what? Minus of F into S. Okay, force is acting in this direction, displacement is acting in that direction. So minus F into S is equal to minus mu square. So minus F into S is equal to u square. We getting Fs is equal to half mu square. So from this formula, making that constant, this constant, okay, questions can be asked. Why, what happened? Okay, clear? So mainly the questions will be based on what is the displacement. So we could write S is equal to mu square divided by 2f. S is equal to mu square by 2f. So this velocity is initial velocity. If you are interested, you can put I or something here. Okay, mu square by 2f. Okay, so this is one formula. Another formula is S is equal to what? This is kinetic energy, right? Initial kinetic energy. Initial kinetic energy divided by the force, retarding force. Okay, so now based on momentum, what will be the formula? What is kinetic energy based on momentum? P square by 2m. Yes, so this one. Clear? Done? Shall I erase this? This is stopping time. Okay, this is again what is stopping time. Clear? Stopping time. Okay, now what is impulse? Change in momentum. Change in momentum. Okay, now mu was the initial momentum and m into 0 was the final momentum. So this is actually force into time. Okay, so we can write the stopping time initial momentum divided by force. Okay, suppose if the path has this path has some friction. Okay, some friction. To maintain constant speed or velocity, what we have to do? We have to burn the fuel or what? If there is no friction, it would have moved with equal or constant speed. So if this has got some friction, okay, if you don't apply any force from our side to drive the vehicle, what will happen? This friction will act as retarding force. Natural retarding force will be there. So if friction is there, if there is a coefficient of friction on the road, then we can say S is equal to what? Mu square divided by 2 mu mg. We can write like that. So no need to by heart the formula. I am showing all this just for your understanding how to approach. So by heart the cutting u square by 2 mu g easy formula, all that drama please don't do. For your understanding I am telling the same formula itself, just put the equation of friction. That's it, done. Then again stopping distance is what? P square by 2 m. What is there? Force mu mg. The handout comes, we will be able to do some problems on this and kinetic energy momentum relation and all. Okay students, so question number 18. So till question number 17 already we have solved those problems in the classroom, or at least that type of model we have already done. So from 18 onwards there will be some difference. Okay, so question number 18. Consider the following two statements. Linear momentum of a system of particles is 0. First statement. This is assertion, reason, question. Linear momentum of a system of particles is 0. Kinetic energy of a system of particles is 0. So then A, 1 implies 2, 2 implies 1, likewise. So which one will be correct? What is your answer? Okay. C. C. Any other answer, Aslam? D. Any other answer, Pa? A. Answer is D. Answer is D. The reason is momentum is a vector quantity, whereas kinetic energy is a scalar quantity. Momentum is vector. The reason is momentum is vector, kinetic energy is scalar. Okay, what is option D? 1 does not imply 2, but 2 implies 1. That is, when kinetic energy of particle is 0, then momentum will be 0. Okay, correct, understood or what? So momentum can be 0. See, suppose one particle, if it is going in this direction, another particle is going in this direction, this momentum and this momentum, if they are equal and opposite, that can be 0. But what about kinetic energy of this? This is mass m1, its velocity is v1, this is m2, this is v2. Kinetic energy will be what? Half m1 v1 square plus half m2 v2 square. But m1 v1, if it is equal to m2 v2, then what this implies? Momentum will be 0, but still kinetic energy will not be 0. Correct or what? See, you have doubt that direction of velocity is to be taken here. Direction of velocity is to be taken here. Even if you take the direction of velocity, what will happen maximum? V1 could be negative. that will become positive here. Clear or what? Work will have negative sign. Work will have negative sign. Potential energy also will have negative sign. The problem with the kinetic, not the problem, the nature with the kinetic energy is what? Even if we put negative for velocities, when we square it, it will become positive. Clear or what? So option D. Done? Okay, so then question number 19 you can do. Okay, question number 19 you can do. That is not a worry. It is little bit lengthy. Need to be careful. Only that thing. Option C is the answer. Question 19. Option C is the correct answer. Please do it. Okay. And wherever you have problem, I will solve. Now come to question number 20. A body of mass 10 kilogram is at rest, acted upon simultaneously by two forces 4 Newton and 3 Newton at right angles to each other. The kinetic energy of the body after 10 seconds. The kinetic energy of the body after 10 seconds. So two forces are acting. Okay, two forces are acting at a right angle. Two forces are acting at a right angle. How much? 3 Newton, 4 Newton at right angle. What they are asking? What is the mass of the body? Is given. Mass is equal to 10 kilogram. Okay. So the kinetic energy after 10 seconds. What will be the kinetic energy after 10 seconds? Okay. What is this question number, children? 20. Okay, fine. So here, what is the answer? Any answer you got? 125 joule. Okay, so you are getting 125 joule. Right. See, children, so the net force is what? Two forces are acting at different directions. This is going to be 3 square plus 4 square. How much you will be getting? 5 Newton. 5 Newton. So this half m delta v square is going to be force into displacement. Force into displacement, correct now? Work done, both work done. So half into mass is equal to 10 kilogram into V initial, okay, V final square minus V initial square. This was starting from rest or what? This was starting from rest. What is the question? Yes or what? Okay, so this will be 0. This is equal to what we need? We just need the magnitude of force. So 5 into the displacement. Is it given? Not given. After 10 seconds they are asking. After 10 seconds. So what is the formula for finding displacement? Constant force is acting. This is not variable force. So S is equal to ut plus half at square. Initial velocity is 0. So this is going to be half into what is acceleration? Force by mass into t square. So this is going to be half into force is how much? 5. Mass is how much? 10 into 10 square. Correct or what? After 10 seconds. So this is going to be how much pa? 25. So displacement is 25. So this is going to be 5 into 25. So Vf square is equal to how much? 5 into 25. 5 into 25 into 2 divided by 10. Okay, so what is oh, they asked the kinetic energy. Oh, right, done. Okay, so what else we need? Vf square is equal to 5 into 25 into 2 divided by 10. So final kinetic energy will be what? Half into m into Vf square. So half into mass is 10 into Vf square is nothing but 5 into 25 into 2 divided by 10. Okay, done? Clear? Over. This okay, so this itself is the answer. No, oh, right, fine. This is not required. Fine. Okay, clear. Done. Okay, children, understood? Okay, thank you. Okay, done. So this half m Vf square is equal to whatever we are getting. This is nothing but final kinetic energy. Okay, done. Clear? So we'll go to next question. So whoever did not get, please take it and pass. What is the next question, children? Question number 21. A body of mass 5 kg is moving with a momentum of 10 kg meter per second. A body of mass 5 kg is moving with a momentum of 10 kg meter per second. A force of 0.2 Newton acts on it. A force of 0.2 Newton acts on it in the direction of motion of the body after 20 seconds. The increase in kinetic energy is. The increase in kinetic energy. So body is moving with a momentum. Body is moving with a momentum 10 kg meter per second. A force of 0.2 Newton acts on it in the direction of motion of the body for 10 seconds. The increase in the kinetic energy. Okay. Getting what answer, pa? 4.4. Done. So change in kinetic energy is what? P square by 2m. Momentum square divided by 2m. Mass will be constant. So momentum is changing here. So change in kinetic energy is nothing but change in momentum square divided by 2m. Already first momentum is given 10 kg meter per second. Second momentum, change in momentum is nothing but force into time. So P2 minus P1 is equal to F into T. We got P2. F into T plus P1. So force is how much? 0.2 Newton for a duration of 10 seconds. So plus momentum we will be getting 12. So that is what. So change in kinetic energy is equal to P2 square is 12 square, this is 10 square, divide by 2 into mass is how much? 5. Yes, so we will be getting how much? 4.4 joule. Clear? Any doubt in this? Anyone comfortable? Okay, so this is question number 21. We'll go to question number 22. Two masses, okay, of 1 gram, two masses of 1 gram and 9, not gram, right? What, 1 g and 10 g, okay, 1 gram, bro. Two masses of 1 gram and 9 gram are moving with the equal kinetic energies. The ratio of their respective linear momentum. Okay, do it fast. Direct question. So nothing is mentioned about any other thing like the velocity. Okay, so we said one favorite formula, root 2mk, correct? Okay, so that's it. So here this is moving with the equal kinetic energy. So this is constant, this is constant. P1 by P2 is equal to root of m1 by m2. What is the mass given? Gram and gram. So 1 is over. Question number 23. Question number 23. A body of mass 2 kg is thrown upward with an energy 490 joule. The height at which its kinetic energy become half of its initial energy will be. The height at which the kinetic energy will become half of its initial energy. So this is nothing but just a what? It is projected with some velocity. How much velocity? V, let it be. So at some height, okay, at some height, if this is the kinetic energy, this will become half. So this height is nothing but here the potential energy will become mgh. So mgh will become the half of the kinetic energy. What they are asking? Simply height. So k by 2mg. Okay, so correct or what? What will be the height? What is the kinetic energy initially? 490. Okay, divide by 2. What is the mass? 2. Then okay, let us put this as 9.8 because this is 49. Instead of putting 10, put 9.8 because 49. Are you getting 12.5? Yes, that is the answer. (24) you leave, that is easy, no? 24 direct question, simple one. Answer will be C. Just mark C. Question number 24. Answer is C. Okay. Come to question number 25. Question number 25. Two carts on a horizontal rails are pushed apart by an explosion of powder charge Q placed between the carts. So two carts are connected and using some bomb explosion that is broken. Suppose if the coefficient of friction between the carts and the rails are identical. If 200 kilogram carts travel a distance of 36 meters and stops, the distance covered by the cart weighing 300 kilogram. Okay, so that is the question. What is the question number? 25. Okay, question number 25. So this is a cart, 200 kilogram. This was connected like this. This is 300 kilogram. So here explosion happens. This goes in this direction and this one goes in the opposite direction. Okay, the distance traveled by a cart of 300 kilogram, correct or what? That is what. So children, here the question I will read again. Suppose the coefficient of frictions between the cart and rails are identical. If the 200 kilogram cart travels a distance of 36 meters, what will be the distance traveled by the cart being 300 kilogram? Okay, so here what will be conserved? Momentum will be conserved. Momentum will be conserved. And the stopping distance comes because of what force? Frictional force. Okay, both are same also. So what is the formula for stopping distance with the momentum? Momentum of both will be same or what? Momentum of this one and momentum of this one will be same. Correct? So we can say first statement is momentum of 200 kilogram cart will be equal to momentum of 300 kilogram cart. Stopping distance based on momentum will be what, children? 2m mu mg. Okay, so this is the stopping distance. Now in this, what all these are? P, 2, mu is constant. Okay, identical. So only mass is different, no? So equate it and get the answer. Clear? Okay, done. So S is proportional to, I could write S is proportional to 1 by m square. Done, over. Things are easy now. So S1 by S2. No, x200 divided by s300. S1 has to leave it. This is equal to 300 square divided by 200 square. So one is given, no? Which one? 200 is given. So let us put here 36. So s300 is how much? How much, pa? 16 you are getting? 16 meters. Okay. Is it clear? Okay. Next one. What is the next question? Question number 20. Question number 26. An unloaded bus. That question, no? An unloaded bus and a loaded bus both are moving with the same kinetic energy. The mass of the latter is twice that of the former. Brakes are applied to both so as to exert equal retarding force. If x and x2 are the distances covered by the two buses before coming to a stop, then what is the distances? Okay, so how can we relate in this question the distance, stopping distance and kinetic energy? What is the formula for stopping distance and kinetic energy? SC is equal to N. Simply K by F. Simply it is K by F. Same retarding force allava. So this is same. Ini enna kinetic energy? Adum same. So will there be any difference? No. X1 is equal to X2. Mark it. X1 will be equal to X2. So option A. Answer for this question is option A, same distance. Okay, done. Right. Next question. Question number 27. What is that? A bus can be stopped. A bus can be stopped by a retarding force F when it is moving with a speed V on a level road. The distance covered by it before coming to rest is S. Done. If the load of the bus is increased by 50% because of passengers, then for the same speed, for the same retarding force, the distance covered by the bus, okay, come to rest shall be. So again, what? Retarding force into distance will be equal to kinetic energy. Retarding force into distance will be equal to kinetic energy. So how to solve that problem? Retarding force into distance is kinetic energy. So F into S is equal to half mv square. Correct or what? Now here what is same? Force is same, then velocity same. So what we can write here? The stopping distance is proportional to what? Mass. So S divided by S2. S divided by S2. S1 divided by S2. Okay. So this is equal to initial mass was M. Then 50% is added. So suppose if it was 1, 50% is added means 1.5. So this is going to be 1.5 M will be cancelled off. So S2 is going to be 1.5 S1. 1.5 S1. So here it is S. So 1.5 S. 1.5 S. Which option? A. Right. What is the next question? 28. Okay, a vehicle is moving on a rough horizontal road with a velocity V. The stopping distance will be directly proportional to V square. Stopping velocity also we have seen, no? So is it direct question from that formula? Okay. So S is equal to V square by 2A. Question number 28, S is equal to V square by 2A. So S is proportional to V square. Clear? So that is done. What is the next question, children? Potential energy. Over, done. Now we will start the concept of potential energy. So put the heading potential energy. Okay, see, potential energy. Okay, potential energy. So this is actually change in potential energy. Okay, this is actually change in potential energy. There is nothing like a absolute potential energy. With a reference to something else only we will be able to say. Okay, so this is actually change in potential energy. So first concept, the very first concept which we are going to study about potential energy is change in potential energy is equal to negative of work done by conservative forces. Change in potential energy is equal to negative of work done by conservative force. Example, gravitational force. This is acting towards the ground. Now, when I take something to it of h, now displacement is in this direction, gravitational force in that direction. So suppose if this is, we consider this height as 0, we consider this height as 0 and we consider here the potential energy as 0. Summa or reference, considering a reference point. Now, okay, what is this? Adanadu? Dumbbells. ஞாபகம் இருக்குல்ல முகேஷ், அப்போ ஜிம்முக்கு போயிட்டு பண்ணிட்டு இருந்தது அதுதான். ஞாபகம் இல்லையோ, நம்ம என்னமோ அதுக்கப்புறம் ஞாபகம் போயிருக்குது. ஓகே, ஸோ ஒரு டம்பல் எடுத்துட்டு இஃப் யூ ஆர் டூயிங் லைக் திஸ், ஓகே, யாராச்சும் சில பேர் தூங்கிட்டு இருப்பாங்கல்ல, அதனால தான் ஐ டுக் டம்பல்ஸ் ஹியர். இல்லைன்னா பால் தான், பால் மாஸ் எல்லாம் பார்த்தாலே தூக்கம் வரும். டம்பல்னு பார்த்தா ஓகே, ஸோ டம்பல். ஸோ இந்த டம்பல் வந்து ஒருத்தர் ஒரு ஜிம், ஓகே, ஒருத்தர் to a height of h. Okay, so actually the mass of this dumbbell is m, so gravitational force is acting in this direction, so h is in this direction, so work done by gravitational force will be what, Tangams? Force on the mg, displacement on the h, this is going to be cos 180. அப்படி பார்த்தீங்கன்னா this is going to be what, minus mgh அல்லவா. நம்ம சின்ன நாள்ல இருந்து when we were small, no, 3 years old baby, teachers taught us what, potential energy is equal to mgh. So here minus comes, right? So that is the reason we say potential change in potential energy is equal to negative of the work done by conservative force. Okay, so this is the first concept. Okay, done. Next one. So here based on this, another thing is, next concept is okay, now see what is the gravitational potential energy you have studied. Means if we have two masses like this, if they are kept at a distance r, this is 1, 2, what is the potential energy? G m1 m2 divided by r. Okay, suppose if you keep two charges q1 q2 like this, distance r, u is equal to k q1 q2 divided by r. So all these things will come here, all these things will come here. Okay, so this is 1, number 2, all these things will come here. Okay, conservation of charges, everything will creep in here. Number 3, okay, now inga vandu or positive charge, it is kept here. Now suppose if we keep a negative charge here, or when we will keep a positive charge itself here. Okay, so what is the potential energy here? K Q divided by R. So சும்மா இப்படி இருக்குமா, or we will have to apply force and keep it like that? பெரிய positive charges here, I'll have to keep like that. Okay, so that potential energy is this. Okay, now what we are going to do, பிடிச்சு வச்சிட்டு இருக்கு. Okay, I want to move மாறி, what will happen? Correct or what? This one will fly away, this one will fly. So at some distance this charge will be flying with some velocity v. Correct or what? So whatever be the velocity here, that will be kinetic energy. That will be a kinetic energy. So if this has got a mass m, if this is mass m, this is going to be what? Half mv square if we consider only mass. What is the other way? This we can say as q divided by r. K q divided by r is what? K q divided by r alone is what? Potential. Can I write like this? This will act as what? Kinetic energy. So we have to write, this is potential energy, but here this will become what? The same quantity will be converted into kinetic energy. This is not the regular formula of kinetic energy, but this potential energy, when it attains velocity, we will have to write kinetic energy is equal to q into v. So this is same as what? Half v square. Clear? Done? Okay, so that is fourth point. Done? Shall I erase this? Completed? Some phone is vibrating, so make it silent. So fourth point. Now fifth point is force is equal to minus du by dx. Force is equal to minus du by dx. Work is equal to integral f dx. Work is equal to integral f dx. So if this is a small work, what we do? This is f dx. So we can write like f is equal to dw by dx. So this work, if we are doing against the conservative force, we can write this is equal to minus du by dx. Clear? Okay, so remember this, f is equal to minus du by dx. Okay, so this is one point. Another point is from the same formula, what we can write? Du is equal to f dx minus of f dx. So this is the small change in potential energy for a small force, for a force acting at a small distance. So if we need full potential energy change, then this is going to be integral x1 to x2 f dx. So remember this. Okay, done. So these are the simple basics. When we go to spring and all, there we will discuss separately. Now these are the basic fundamentals. So with this itself we will do some problems. And related to spring, elastic force, gravitational force, electrostatic force, for all those things we will do separately. Okay, so before coming to the handout, I will give you some simple problems here and let us make the basics ready. Suppose F is equal to 2x, children. F equal to 2. Okay, potential energy at x is equal to 1 is 10 joule. Okay, potential energy at x is equal to 1 is equal to 10 joule. Okay, find U at x is equal to 2 meters. Generally, work power energy is considered as a small chapter, but we cannot consider work power energy as a small chapter. Electrostatics, gravitation, collision, everything will come here. Okay, conservation, everything will come here. So we will cover in detail, then we'll move. Okay, children. So here, what is the formula? U is equal to minus integral x1 to x2 f dx. Okay, so here what is this? Change in kinetic energy. U final minus U initial is this. X is equal to 1 will be U initial. We do not know U final. That is, this is at x is equal to 2 meter. This is just like x is equal to 1 meter. Here it is 2 meter. Okay, fine. That is what. Initial potential energy is given as 10 joule. So this is equal to integral minus x is equal to 1 to 2. F is given as 2x dx. So this is going to be 2x square by 2. 2 will be cancelled. X square, putting the limit 1 to 2, minus will be here. So this is going to be what? 4 minus 1 going to be 3. So here UF is equal to minus 3 plus 10. This is going to be 7 joule. Is it clear? Please look at the solution. Comfort yourself. If you have any doubt, please ask. Clear? Right. Another question. F is equal to 3I plus 4J. 3I plus 4J. Potential energy at 0, 1 is equal to 10 joule. And potential energy at 2, 3 is equal to what? Okay, got the answer? 24. Any other answer? Okay, any other answer? 3. Any other answer? 5. 5. தங்கம் பேரு சக்தி ராகேஷ் சக்தி பொது. Okay, any other answer? எடிட்டிங் மாதிரி இருக்குது இப்படி சொல்லிட்டு இருக்கு. வேற யாரோட குரல் வருது? 7 ஜூலா 7 ஜூல் 1 ஜூ. oh my god, so வருது 6 ஜூல். சொல்லுங்க, ஆன்சர் வேணா சொல்லலாம். இமேஜ் ஏற போகுது, நிறைய போட்டி நடந்துட்டு இருக்கு. என்னென்ன ஆன்சர் இருக்குது? லாஸ்ட் 3 செகண்ட்ஸ் சொல்லுங்க. 1 -4 -5 பேரு சபரீஷ் -5. ஓகே, அவ்வளோதானா? ஓவர், போட்டி முடிஞ்சது. ஓகே, பார்ப்போம். நான் போதும். ஓகே, ரைட். ஸோ என்ன பண்ணலாம்? ஓகே, ஃபைனல் பொட்டன்ஷியல் எனர்ஜி மைனஸ் இனிஷியல் பொட்டன்ஷியல் எனர்ஜி இஸ் ஈக்குவல் டு மைனஸ் ஆஃப் யூ இல்லை எஃப் டிஎக்ஸ், மைனஸ் ஆஃப் எஃப் டிஎக்ஸ். ரைட். ஸோ ஃபைனல் பொட்டன்ஷியல் இருந்து தெரியாது. இனிஷியல் இஸ் 10. திஸ் இஸ் ஈக்குவல் டு மைனஸ் அங்கே இருக்கட்டும். So first one is from 0 to 2. 0 to 2. 0 to 2. One side we will find out. Correct or what? One side we will find out. So f ku I in x direction. This one. So 3 dx. பிரச்சனை இல்லைல்ல? ஓகே. Plus integral 1 இலிருந்து 3 வரைக்கும். 1 to 3 with j who is there? 4. What? dy. Done. So this is nothing but 3x. Okay, negative இங்க இருக்கட்டும். 0 to 2 plus this is going to be 4y. 1 to 3. Correct? So this is going to be minus 6. Then இங்க plus 4 into 3 12 minus 4. இப்படி தானே? Correct or what? So this is going to be, this is what pa 8. So 8 plus 16 14. So minus 14. Inga uf inga irukkudu. We will throw this that side. This will become 10 minus 4 joule. Aslam avargale vaazhthukal. Getting children? Okay, this is not a big deal. This first time we are seeing, so slowly we are doing. Okay, hereafter you won't make this won't be a trouble for you. Correct? Done.